All right, guys, so in this video, we're going to keep looking at more of our inverse trig functions, but we're going to take a look at cosine and tangent this time. So let's go ahead and start by looking at the graph of our cosine function. So just like we talked about in the previous video with our inverse sine function, we have to limit this cosine function to a smaller piece of its domain so that we ensure that it is a one-to-one function. Because of course, just looking at this cosine function, although it passes the vertical line test, it certainly does not pass the horizontal line test. So we can't look at the function on its entire domain, but instead we're going to limit it down to a smaller chunk. Now with the cosine, if we want to make this a one-to-one function, we're going to focus on this piece right here from 0 to pi. Okay, that would maintain the entire range of the original function from -1 to +1. So we're not losing any y values, but it's now a one-to-one function. Okay, so now if we think about the inverse then, remember the inverse function switches the domain and range. So we're saying here that the domain of cosine is going to be between 0 and pi, so that will be the range of the inverse cosine. Okay, so the range of the inverse cosine then is going to be an angle between 0 and pi. So the inverse cosine is always going to give us an angle that's either in quadrant 1 or quadrant 2. All right, and then the domain of the inverse cosine, that's going to come from the range of the original cosine, which is from -1 to +1. Okay, so basically what this is saying then, if we think about what this inverse cosine means, okay, so our cosine function, you put in an angle and you get out an x value on your unit circle. So the inverse cosine then is just going to switch the input and the output. So now you're going to put in an x value on your unit circle and you get out an angle. So for example, I could say we know that the cosine of pi over 4 is equal to √2/2. So this is equivalent to saying that the inverse cosine of √2/2 is equal to pi over 4. So the inverse cosine, you're just asking a different question. You're saying, if this is an x value on my unit circle, what's the angle that it came from? Whereas our original cosine function is saying, for this particular angle, what's the x value on our unit circle? So you're just looking for the opposite piece of information. You're essentially just going backwards. Okay, so let's go ahead and let's look at a few examples with our inverse cosine. Let me go ahead and pull up my unit circle. Okay. Oops, that's my tangent. Okay, so inverse cosine. All right, so we're looking to find the exact value. And for inverse cosine, we're just limiting ourselves to the top half of our unit circle. So we're just focusing on the angles between 0 and pi. Right, so the inverse cosine, we're always going to be looking for an angle. So when I ask you to evaluate inverse cosine of 1/2, basically what I'm asking is the cosine of what angle is equal to 1/2. We're trying to solve for the angle. All right, so if we look over here on our unit circle, all right, we're just looking for where our x value is a positive 1/2. So x value is a positive 1/2 over here in quadrant 1 at an angle of pi over 3. So pi over 3 is our answer. All right, all you're doing is you're looking for the angle that corresponds to this x value. All right, let's look at the second one. All right, so inverse cosine of √3/2. So again, this is asking us the cosine of what angle is equal to √3/2. So we're trying to find the correct angle between 0 and pi that answers this question. right? Okay, so if we look over here, okay, so we're looking for an x value of root 3 over 2. So that is going to happen right here, again in quadrant 1, all right, at an angle of pi over 6. All right, so cosine of pi over 6 is equal to root 3 over 2, which means the inverse cosine of root 3 over 2 is equal to pi over 6. All right, one last one with our inverse cosine. So this one's asking us inverse cosine of a negative 1/2. So again, we're trying to answer the question, cosine of what angle theta is equal to a negative 1/2. So if we look over here at our unit circle again, we're looking for an x value of negative 1/2. And remember, we have to focus just between 0 and pi for our inverse cosine function. Only the top half of our unit circle exists right now. So x is equal to a negative 1/2 right here in quadrant 2 at an angle of 2 pi over 3. Okay. All right, so that is our inverse cosine function. All right, so you're given an x value on your unit circle, and you're trying to find the corresponding angle between 0 and pi. All right, let's go ahead and take a look at our inverse tangent as well. All right, so here's our inverse tangent function. All right, again, fails the horizontal line test, so it is not a one-to-one function on its entire domain. So we're going to limit it down to a smaller piece of its domain to make it one-to-one. All right, so with our tangent function, if we focus just in the middle here, between negative pi over 2 and positive pi over 2, we still have the entire range of the original function, all real numbers, but this is now going to be one-to-one. It passes that horizontal line test. Okay, so we're limiting the domain of the tangent function to negative pi over 2 to positive pi over 2, which means that becomes the range of our inverse tangent function. Okay. So with our inverse tangent then, it's always going to give us an angle between negative pi over 2 and positive pi over 2. So it's going to be an angle in quadrant 1 or 4. So that was the same as our inverse sine function. Okay, so inverse tangent has the same range restrictions as our inverse sine function. Okay. And then the domain of the inverse function is just the range of the original function, which is all real numbers. All right, so for inverse tangent, we can plug any number into it, and it's going to give us out an angle between negative pi over 2 and positive pi over 2. All right, so let's go ahead and take a look at a couple examples. Let me again pull up my unit circle. Okay. All right, so let's take a look at this first one. So inverse tangent of negative 1. Now inverse tangent again is always going to give us an angle between negative pi over 2 and positive pi over 2. So we're just focusing on quadrants 1 and 4. Okay, so inverse tangent of negative 1. So first of all, because our value here is negative, I know we're going to be focusing particularly in quadrant 4 because that's where our tangent is going to be negative. And with these, we're going to have to think a little bit harder than we did for sine and cosine because it's not just pulling a value directly off of the circle, but we have to think about what our ratio of y over x would give us. Okay, so if we're thinking about where the inverse tangent would or where the tangent would equal negative 1, I should say. So we're thinking tangent of what angle theta is equal to -1. Well, if we think about our unit circle angles, the only way that we could get a -1 is if both the numerator and the denominator were the exact same number. And the only place that that happens is right here in quadrant 4 at 7 pi over 4. Our x value is a positive root 2 over 2. Our y value is a negative root 2 over 2. So of course, if you were to divide those, if we think tangent of 7 pi over 4, so negative root 2 over 2 over positive root 2 over 2, that would just give us -1, which is of course what we're looking for. And the only thing we need to be careful with here is just like we talked about with our inverse sine function, 7 pi over 4 does not fall between negative pi over 2 and positive pi over 2. So instead of using an angle of 7 pi over 4, we're going to have to use an angle of negative pi over 4. So our answer on this one is negative pi over 4. Okay, so any of these inverse trig functions, if your answer is in quadrant 4, then your answer is going to be a negative angle. Okay, let's go ahead and look at part B. So inverse tangent of root 3 over 3. So again, we're trying to figure out tangent of what angle theta is equal to root 3 over 3. Okay. All right, well, just to kind of think about this, okay, root 3 over 3 I know is a rationalized number. So this originally came from 1 over root 3. So if we think about looking at our unit circle over here, okay, we know that tangent is y over x. So if we want to have a 1 in the numerator, we had to have had something with a 1 in the numerator from our unit circle. And if we want a root 3 in the denominator, we had to have had something with a root 3 in the denominator on our unit circle. Well, our only options on the unit circle are a 1/2, a root 3 over 2, and a root 2 over 2. Okay, so I know we're not looking at the root 2 over 2's because there's no root 3's in there. That isn't going to give us what we're looking for. So it's either going to have to be the pi over 6 angle with the root 3 over 2 1/2, or the pi over 3 angle with the 1/2 root 3 over 2. But in particular, we want the 1 in the numerator, so that means we have to have the 1/2 in the numerator, and we want the root 3, or that had to have come from a root 3 over 2 in the denominator. Well, if we think about that then, that means our y has to be 1/2, our x has to be root 3 over 2, so that would have to be then our angle of pi over 6, which has those coordinates on our unit circle. So our angle for this one is going to be pi over 6. All right, and then lastly, inverse tangent of negative root 3. Okay, so I'm going to think about this in the same way. So we're thinking tangent of what angle is equal to negative root 3. Okay, so it's a negative number, so I know we've got to be down here in quadrant 4. Tangent would be negative in quadrant 4. Okay, and we're trying to figure out what angle theta this is. Well, again, I know we're going to need a root 3, so it can't be our 7 pi over 4 angle because there's no root 3's in there. So it has to either be the 11 pi over 6 or the 5 pi over 3. So if we think about this, okay, tangent of theta is equal to negative root 3. So that would have come from a root 3 over 1, essentially. And if we think about our unit circle values, that had to have been a root 3 over 2 in the numerator and a 1/2 in the denominator. I'm not sure yet where the negative goes, so I'm just going to leave the negative out front. So if we look over here at our potential answers, all right, we know that tangent is y over x. So we need a y that's a root 3 over 2. We need an x that's a 1/2. So that has to be our angle here of 5 pi over 3. Now again, 5 pi over 3 doesn't fall between negative pi over 2 and positive pi over 2. So instead of 5 pi over 3, we're going to use negative pi over 3. All right, so that is our final answer there. Okay, guys, so I'm going to end this video here, and in the next video, we're going to start looking at compositions of functions and their inverses. So keep watching the next video for some more examples of what we can do with these inverse functions.